Okay, our next speaker is Michal Ambler. He's leading Ernst& Young's data science and AI team in Prague, focusing on design and implementation of end-to-end solutions with AI and ML components. Although he has experience with AI application development from several industries, his primary focus in recent years has been on personalization in retail banking area, combining AI methods and optimization algorithms. The title of his presentation is Recent Approaches in Retail Banking Marketing Optimization.
Okay. Hi, everyone. Am I heard? Yeah, it's great. So, want to welcome you here today. My topic today is revolving around AI, around retail banking, and around combination of different methods into a transformation of the way that retail banking actually works with marketing offerings, with targeting customers, something that some other industries that were more digital native actually acquired already some time ago, especially when you think about e-shops and e-commerce in general, which have always been very much online. There, when you think about modeling and optimization and recommendations and using AI and different advanced methods for smarter offering of products or services to clients, it's native in there. But in the banking area, since banks have been here for a long time, it has been quite a struggle. My point of view comes from Central and Western Europe, so that's also something you should bear in mind when I speak. It comes from several years of experience in this specific area. Of course, I'm leading AI and data science team in Prague, EY office. We do all different sorts of applications in this area. We don't work only for banks and not only in marketing optimization, but this has been a very, very interesting topic for us. You might think of EY as a consultancy company. So basically us speaking and doing pretty slides and being very clever about it. But we also have AI data science practitioners. We have programmers. We have people that like to invent new digital solutions. So this is where this comes from. These kinds of transformational projects in banks are very complex because they usually tend to, it's not a greenfield thing. You tend to go into very deep-rooted mindset of how marketing works, and you need to have transformational change in several different departments in the bank. You sometimes need to, define new governance. You need to take care of, enabling your data solutions. So that's the technical part, which, Central Western Europe is pretty mature in this, but not all banks are, so it's quite varied. And it's also an AI and data science exercise. So since this is a combination, this is something that we like, and that's why we do it. And that's why it's not always very simple for specialized, simply AI company to do something like this, because usually it's a mess, these kinds of projects. They take a lot of time, and there's a lot of back and forth. So I'll go from the position of the problem, actually, and then try to deep dive a bit. Well, deep dive is too strong a word, but to focus a bit on the technical side of these projects, what is actually being used, and what is something that could be maybe called best practice. But best practice still means that a lot of very well-established banks with large portfolios haven't actually gone all the way to have complete solutions. So the departing point, why I think this is interesting and why it also has impact on any of us, because we all have accounts, we all have different kinds of banking products, we all have experience with being offered things, being called by bankers, being try to be persuaded to earn more for the bank, naturally. The way that most banks today actually work with retail portfolios is characterized by three things in my experience. So first one is incoherent work with the data layers. So since the bank actually evolved in such a way that maybe the risk part was very mature at some point in time and needed very good data for their exercises and their modeling, and that kind of worked, then there were parts of the bank that just evolved serving, service functions and customer service functions, for example. So data science teams that try to help call centers to work in a better way, to invent different kinds of solutions. And then the last one is basically the marketing area. So there are still some others left that didn't go through digital transformation very much, but the marketing area is problematic because when you imagine having a retail portfolio of several million clients, maybe, then you have a lot of data about those clients. So the bank knows a lot about you. They have all the transactions. They usually have some extra data intelligence coming from some external vendors or through just the ability of the data science team to derive insights from what they know about you. They might know, your family connections, and all that goes into, for example, propensity modeling. So that's something that's pretty common. I guess everybody does that to some extent, but that's just the first step. And different parts of that knowledge of the customer might be on different places. So in the Central European area, in the past couple of years, there have been large projects targeted at unifying this customer 360 view, or however you call it. Usually it's still not everything that you might need, but it's a pretty good start. But it didn't happen everywhere. Then a non-technical departing point, fragmented interests. What I mean by that is when you imagine large bank, there are guys focusing on just accounts. There are guys focusing on loans, on mortgages, maybe some insurance, maybe some extra products. And these guys usually sit either in different parts, different departments. They have different KPIs. They tend to have sometimes even different bosses. So there's somebody who heads retail, of course, but when you have the product factories, product teams, they might have very different motivations. So me, Michal, I'm client of the bank. They would like to get the most of me, right? So who's going to take me? Am I going to be offered a new loan? Do I want to have an insurance, some extra insurance? Maybe I'm good for a mortgage. So what happens if I'm a great potential client for any of these, right? At that point, it becomes a fight. And in any bank, in those million of clients in portfolio, there is this upper layer, which is actually the highest potential. And these guys are being torn apart by different product factories in the bank, trying to get the most of this potential because it's their KPI to maybe sell more, to have higher margins, whatever metric this is. And this tends to be quite a problem when the portfolio is limited, and especially when the times aren't that great. The bank metrics are not signaling very good things to shareholders, maybe. So then when this panic creeps in, everybody wants to just send all the offers to the highest earning guys who actually might want that product. And when I mentioned propensity models, there tends to be quite a lot of them in these banks, and they are not usually governed in the optimal way. So you'll have maybe 10, 20, 30, 50, some banks have even hundreds of propensity models for different purposes. Because somebody from loans maybe have come in and said, I have this new product, it's a loan, but it's somehow like a bit different of a loan. So I don't want to use that typical propensity models because it doesn't fit me. Maybe I need something new. So a new model is created. And then you have really hundreds of those, some, older ones, some using advanced data from online channels, some real-time triggers. And without having like a uniform platform to work with them, it's usually quite a mess. It's hard-coded somewhere, and it really depends on how strong the product team actually is in forcing the data science guys to maintain this in a good way. So, what are the trends that it's, what is being done about this? There have been years and years and years of trying to clean this up, this jungle of things that were happening. For one thing, there is usually quite a lot of people involved, not only those, inventing those products, but also those that need to gather data. Sometimes it's on ad hoc basis, so those models might be calculated every day if it's well governed, but some maybe monthly. And a lot could change in a bank data layer in a month, right? I've seen personally that some models just would never work by themselves, so every month there was something quite different in the data layer. So every month somebody had to go in and just do bug fixing and change it all. And then several man-days were spent just on fixing this one model, and there were hundreds. So the motivations are to save costs like this and to streamline the way that these departments actually work. But also, if I'm able to utilize my portfolio potential in a better way, then I'm improving my top line. So I might improve my revenues drastically, if not margins and something else. But revenues, look pretty clear from this. If I'm able to find those guys like me that need that mortgage really a lot, then there is a lot of money just hanging around in space. And I have a lot of information about those clients, so I can contact them and be quite knowledgeable if it's a good idea. And of course, there are other motivations. The components that are used to this, for this, there are several of those. Again, some are technical and some are more functional or business relevant. So you see AI models. So those AI models are mostly those propensity models, to be honest, right? So propensity models in such a way that you might use really rather basic deep learning techniques for today's environment. So those are no transformers, right? And generative AI, those are simpler deep learning techniques, but they are still AI models. But typically for different products, you will have different approaches. For some of those, you'll just have logistic regressions because it's just so simple. And there's not much data to work with. And when you have tens of these models, then there is a space for optimization. So suddenly, you need a way to actually judge what models to use for which clients, and optimization comes in. And optimization in such a way that it could be really old school techniques of linear programming, finding an optimum in a limited space defined by the AI models. I will come back to this. You also need to have some kind of business rules, because you can imagine that there's difference across banks on what they really need for the business, what kind of products are strategic for the next quarter, what kind of products and services are strategic for our portfolio as such. And this comes from the top, from the management. And you might want to what's called hyper-personalize, which means that when you get that email or that call, the thing that you're actually offered is going to have personalized attributes. So not only the interest rate, but there could be other things really personalized for you, even the message itself. And then a problem of somehow aligning real-time world, which is very sexy these days and very interesting technologically, and the old school batch approach, meaning we will just shoot out offers once in a month to vast majority of our portfolio, which is the usual old school approach, because it's technologically easier. So if it fails, you can maybe do it tomorrow or the day after, or maybe even next week if all the IT guys are on vacation. But if it's running daily, it's really, really hard, to keep this running with the old tools. And then, of course, we have some enablers, but those are mostly, really data governance and reporting related. So those are not that sexy, so I will skip those. So how are those core components actually combined together? When you have a suite of AI models and you, as a bank, used to use them in such a way that you created data pipelines for different types of products using those models to identify the high potential part of the portfolio. So if I think about a loan, there might be 200,000 clients eligible for that loan. So from compliance legal perspective, I can offer them this loan, right? So for example, they're not children, right? They're adults. I might also want to have other enablers in place before I'm even able to use the model. When I have the model, I'm scoring those 200,000 clients, and I think, okay, so if they actually take it, then I need to be able to process it. So there might be an upper bound to what I want to send out, or maybe my emailing is quite expensive, so I don't want to send it out to everybody. So I'm going to say, okay, let's send it to about 50,000 clients, and let's do a cut somewhere around there. And they say to their data science guys, show me the distribution of the propensity model, and let's find how it works. For many of those models, those are actually simpler models, so it's fit to some kind of distribution, so you still have to cut it somewhere. And you say, okay, I take those 50,000 of the highest scores. You take those, and you send emails out, and you're offering stuff to clients. This is the old way. And you can have more intelligent models, better models, so the conversion rate after this is better. But it's still basically a manual approach, because the AI modeling filter is actually there somewhere, but it's one of different 20 conditions that you apply on the portfolio to isolate them. What you need also when you want to up your game a bit is to have some other data other than those that you use in the modeling itself. So for example, in one of those projects that we do, you have a lot of interaction with your controlling department when you need to get the revenues and the margins calculated in a very granular manner. I didn't believe it, but many banks don't actually know the revenue on a given contract. They don't have it in their data. They just need to work on it ad hoc when it's needed. But otherwise, this is calculated on some aggregated level, portfolio level, product portfolio level. But if I have a contract and I would like to know what my probable lifetime revenue is, then this is a complication of itself, right? So when I have this, I can actually combine these two, and I can say, okay, so I'm actually modeling my expected revenue for that given product, which is already quite good, right? Because it gives you some other kind, some better type of information, and you're preparing your way to actually do the optimization later when you need to have a common scale, right? You cannot optimize models which have been trained on different data and have different scales, and then it's a mess. One problem here, and I'm not going to say the solution to any problem, I just want to show that it's a bit complex. Of course, you communicate a lot of things towards your clients which are not sale offers. They're just some kind of service, care messages. Again, quite a trend. So banks tend to set up their KPIs in such a way that you might want to have, for every sale message, you want to have 2 care or service messages, because you just want to make sure that you don't bother the clients, us, that much. And you have rules around this. But how do you model these non-sale messages if you want to optimize it all in one space? Because we are still the same people, right? We're getting the messages from the bank, and it's still me. I'm getting the sale messages, I'm getting the non-sale messages. So I have a capacity of absorbing these messages. I don't want to get 20 of them every day. So there need to be rules around this. And this is quite a problem. Some banks actually even model expected revenues on the non-sales messages. This is quite a weird exercise when you think about it, because there is no sale, of course, from the non-sale message, at least not primarily, but you can find different rebound effects on this and model it in some way, but that's very deep data science, and it's actually 100 ways to do this. So then, when you have the models, and let's say that you know that they're scaled to expected revenue, so they're somehow comparable. You can ask yourself, okay, so if I have those million clients and I have limited space of what I can send them, because it can only be, I don't know, 5 messages a month, you have always a rule like this, because otherwise you're over-contacted and you go away, you're angry, you're calling to the call center, just leave me alone, finally. So you have some kinds of rules around this. You can try to optimize what kind of offers to actually send out to your limited space. It could be very simple linear programming exercise where you just combine the model scores and then you get a result. So to every client in that space, you have that one best offer against the constraints that are there, which is mostly the capacity. So simple linear programming problem. But there is a lot of other problems that you need to solve because you're not in a data science bootcamp, right? It's a bank, so it's quite complex, and there's many, many other problems that you need to solve. So which are those? What if I just always prefer distinct patterns in the portfolio? So what if I always prioritize the same products to the same clients because the portfolio is static, more or less, tends to be. So me, Michal, I always get the mortgage offer like every other month because that's what that's what I have affinity for. That's why I'm in the modeling somewhere in the top, and I always get this. I never get anything else because it's a simple math exercise, and this cost is just the highest. So I'm good. But that's probably not what you want. It's always a combination of things. Maybe that you have a lower bottom of clients which actually are not that high potential. But why do I want to communicate to high potential clients? Maybe they just take the offer themselves. Maybe they don't need to be communicated at all, right? If they're affinite to having a mortgage, they might take it later. You don't need to bother them, like, we have a mortgage. Do you want to take it? Maybe it's better just to leave them alone, right? And maybe you want to spend your time and energy on those that are somewhere in the middle or lower to the bottom, less potential, but the difference between do and no do action is much higher than for those guys who actually know what they want, so they don't need you to remind that the bank has loans, right? And of course, you have a problem of passive channels or inbound channels, how we call it, smart banking apps, internet banking, where you have no idea where the client actually appears in there so that you're able to communicate on them. Nowadays, I guess many of us just check out mobile banking app like every day, maybe even multiple times a day, but there are people who just go there once a week, and you have no way of telling when it's going to happen, so it's very hard to optimize on this. So, and this is the toughest part, which is actually the most interesting part, even for us when you do these projects. So how do we actually tame the optimizer from being a simple math problem to being quite a complicated math problem, but also having some kind of added value to the business? So it's not just something that the data guys are playing with and we can't use this, which happens quite a lot. You need to define your levers and constraints for the optimization problem. This is a strenuous exercise because there you go actually into those different points of view of those different product guys, CFOs, marketing people, and whatever, and you say, guys, you have just one portfolio. We need to align what we do with it and what kind of rules we put in there. So obvious levers and constraints are we have limited the capacity for some channels. So if you have a call center and you want to call people with product offers, you cannot call 100,000 clients a day probably. So you only have very limited space. Similar probably to emails, or if they have SMS or whatever. And then you have those channels that have unlimited capacities that you work with differently. But there are other levers and constraints that you can work with. You want to have limited amount of messages to the client in a given time frame. You might want to have upper and lower bounds on those propensity models. You might want to have a maximum amount of offers of a given product that you send out because there might be some special bonus to it and you don't want to pay it to 100,000 of clients, maybe just for the couple of thousand which are first. And you also have some very fixed business rules which are very specific to the bank. And when you combine these, it's actually becoming quite complex. If it's a linear programming problem, then it's very hard to say how long it's going to run, for example, because you have lots of constraints. And when you have users work with this, which we do, then there's actually no way to tell how long it's going to be calculating for a given problem. It could be an hour, it could be 5 hours. It really varies. Yeah, and what you also want to do is you want to analyze and simulate what's going to happen. So if I have this setting for the optimizer, what would happen tomorrow? What would be my number of sales? What would be my revenues? And to sum this up, and you can also combine this with real-time processing, and then it's going to be a very, very complex exercise. They say that basically almost no bank is fully in this mode, able to process this all together. And some final key takeaways from my side. These kinds of problems are very complex, so you need both the technical but also the business background. So it's not just a data science exercise, but the data science exercise inside is very, very critical, because if you don't know the mechanics, you're never going to solve this, and you're just going to promise to business all different weird scenarios that can never be fulfilled. And you also need to make sure that there are internal people that can do this. We are vendors, for example, but we cannot supply this to a bank which has no idea what optimization is, because then just endless explanations, and after 2 years, you just write off the costs, and you're going back to the old marketing world. That's it. Thank you.
Thank you for the great presentation. Unfortunately, we're running late, so if anyone has any question, you can do it after. Thank you. Well, yeah.